been translated vertically up or down, and if it has been rotated in terms of the slope. But we'll come to that when we deal with graphs. So now we're looking at completing the square method. All right. Before I go further, let me say that when we talk about square in terms of algebra, for instance, something like x plus a all squared, or you talk about x minus a all squared, a square term is always positive. The least number you can get out of this is a 0. It's never going to be negative. You can never square anything and get a negative answer. So what happens, what is similar, what is peculiar to a square, equation? Let's square this out. X plus a times x plus a, that's going to be x into x plus a into x plus a. X squared plus ax plus a squared, and that gives x squared plus 2ax plus a squared. That's for this one. If you do this one, you're going to get x squared minus 2ax plus a squared. So you can confirm that by expanding this like I just did here. You see it's correct. Do it now, don't wait. You'll see that it's the same thing as this one. So the only difference is that this is a plus and this is a minus. What does it now mean to complete the square? Good. Let's assume that you have a problem that looks like this but doesn't have this term. It just looks x squared plus 2ax. X squared minus 2ax. To complete the square means that add the missing link and let's have it in that form. To complete the square means add this missing link to something that looks like this and let's have it in this square form. All right, and that's the only thing you need to do when you're given a problem that has to be completing the squares. So, for example, quickly, we are yet to get into the nitty-gritty of it, but let me just give you this example. If you've got something like x squared plus 6x, and I said, complete the square. Go on, complete it. What do you need to do? You can think about this as x squared plus 2 times 3x, right? And then you're like, what do I need to add to this? Oh, 2x squared plus 2ax. So this is like the a, right? So a squared is what we're to add to it. So 3 squared. Now that's complete. Complete this one. X squared minus 7x. Complete it. This becomes x squared minus 2 times 7 over 2x, right? So what am I to add? This is the a term there. So 7 over 2 all squared. And it's complete. It is complete because if I want to write this as a square now, it's just going to be x plus a, our a is 3, all squared. And if I want to write this as a square, it's just going to be x plus, sorry, there's a minus here, so this is minus a, x minus a, and our a is 7 over 2, all squared. So the sign here is what lets you know that it's a plus a or minus a. But this is an a squared anyway. And that's the a. This is the a squared, so this is the a. And then you have it completed. So if I write something like this and you have to complete it, all you need to do is look for the missing term by dividing this by 2. Whatever you get, square it. Divide this by 2. Whatever you get, square it. And that gives you x minus a or x plus minus a. And here you've got x plus a, because our a is 3. But do you realize what you've done? If this is my question, and you get this, because you added 3 squared, then you have added 9 to the question. And because you've added 9 to the question, you have to subtract 9 again